PCNSE Certification. Okay, this is the Palo Alto Networks Certified Network Security Engineer. And in this course, we're going to go through everything that's required for the certification for the current version, which is version 10. Okay, so security policy definitions. The security policies on a Palo Alto firewall are the part right up to where you get to the profiles that you are configuring for your URL filtering and so on. So this is the policy that either allows or denies the traffic. Okay. It does incorporate security profile, but they are two different things. So don't think the security profile and the security policy are interchangeable, because they're not. They're two separate things. The profile is only evaluated should the security policy be an allow rule. And for this, for the security policy, there's multiple match conditions. There's security zones, source and destination IP address, source user, user ID, service or the port, application ID, and you can even get into source and destination devices through HIP profiles. Okay, and at the end of all this, the end of the policy is a security profile, and that's where we get our content ID from. So it only evaluates based on an allow policy, and contains, this is where you set up your objects, the antivirus policy, vulnerability protection, anti-spyware, URL filtering, file blocking, data filtering, and wildfire analysis. And we'll go more into those later on, obviously. Okay, so security zones. So Palo Alto firewalls are zone-based, which means they flow from one zone to another, and that is how it initially looks at the traffic. So when it's evaluating a packet, it will look at the traffic, and the first thing it does in its session setup or its fast pathing is it looks at the source zone. That way it can evaluate the packet against any zone protections or DOS protections that are there. Zones within the network should be used to logically group services or resources into segments. This is sort of based on the purpose or shared common risk level, as it says on the slide. Basically, if you have 3 or 4 DMZs, for instance, you wouldn't put them in DMZ 1, 2, and 3, because if they're all the same, then you just have them in the same zone. Of course, there are caveats to that as well. Zones are specific for the type of interface. So you can't, for instance, have, say if you had DMZ 1 and 2, and one was a layer 2 and one was a layer 3, they couldn't be in the same DMZ zone. So there are layer 3, layer 2, tap, and virtual wire. And those are the zones that you can configure. Okay, so as I said, when we look at the caveats of traffic between zones or in zones, look at interzone traffic. Interzone traffic is, as the slide suggests, within a zone that is allowed to move freely and referred to as intrazone. So all intrazone traffic is allowed by default unless blocked. And this is really important when you start to think about, if you have multiple interfaces in the same zone, you have to understand that the traffic between those is going to be allowed because they're within the same zone. Interzone traffic is, as it suggests, it crosses from one zone to another. So from inside to outside, from inside to DMZ, from outside to inside, wherever, that's where, and that is denied by default. A security policy must reference a source and destination zone. Well, so yes and no. It must reference a source and destination zone, but of course any is still a valid source or destination zone. So you could still have inside to any of the zones for your really common sort of rules. So if you had SSH services that you wanted to run out across all your entire network, you would do from inside or from your particular trusted zone to all zones, and that would be a valid representation, a valid rule. Okay, now this is the traffic processing sequence. You can do a quick video now. Okay, so when we set up a session, because we're looking at fast pathing and everything like this, the first thing that the firewall does is it looks to see if the traffic is matching an existing session. Okay. Existing session. Right, so let's assume for this particular example that it doesn't match an existing session, because I want to draw the top line first. So let's say it doesn't. Alright, so the first thing it does is it looks at the source zone. Okay, so source zone. Then once it's found the source zone, it needs to look and see if it needs to apply any of the zone protections or DOS protections that are on that zone. So that's the next thing it does. Zone protection. I do apologise for my writing, it's absolutely terrible. So once it's done that, assuming everything is still okay and it hasn't got to be dropped because of that, it then goes on to... Oh, no, it's the wrong one. Hang on. I promise these videos will get better at some point. So the next one along then is going to be, so yes, we've got source zone, we've got zone protection, and the next one that's going to be going along is the forwarding lookup. Including PBF, so if you have any policy-based forwarding rules, that needs to be looked up as well. Once it's done that, obviously it knows where its destination zone is. Including DNAT. Okay, so if we have a packet that is going into the outside and it is destined for a server inside, then it's going to check up the DNAT rules as well, because the destination zone it needs to know where it's going, and then it looks up its DNAT lookup, because it needs to find the destination zone, because NAT works on the pre-NAT IP address. So as it goes through the firewall, it's going to need to see what the destination NAT is, because it needs to change that destination NAT, but the zone lookup is already there. Okay, so then we're going to look for the security policy check. Security policy. Check. The security policy check, that's the security policy we went through before, so is it allowed through, is the packet allowed through based on the source zone, zone protection and the destination zone. At this point though, the app ID is ignored because it hasn't got enough info. ID ignored. Assuming all is well and it's allowed through, then we have, I'll do this in orange, session setup. And now we have a session. So now that we've got this session, it's assigned the session ID. I'll just write that on. Assign ID. So now it's assigned the ID. So now we know that we need to allow the packet through, but now we need to start evaluating it based on our security profiles. So do these in green based on the fact that it's all good. Okay, at this point, it's the same whether we would have had an existing session here or we've got the session set up. So if I just go back to here and just move that to there, because then that basically comes in over there and then goes down as well, because now we're going through the profiles. Okay, so because all is well, we know that we're going to look at our application ID and our content ID to check and make sure that we're okay with it. So it's going to get inspected. ID. Okay, now as that's inspected, there's a couple of things to take into consideration, and one of those is whether it's encrypted or not. Okay, and the process for this is fairly simple and straightforward. So if it is encrypted, so yes, then we need to look and see whether does an encryption policy exist. If one does, then we decrypt. If not, then it goes on. If we decrypt, then once it's decrypted, it goes back to here and it goes back through the ID and it gets looked at and it gets evaluated. If not, then we move on to the next stage, which so that's now going to be the enforcement stage. So the enforcement stage, then all the security profiles and the security policy are enforced, because security policy relies solely on pre-NAT IPs. So at that point then, as long as everything is okay and it's been subject to the profiles, so this is profile check, and application. Okay. And then at the end we have forward traffic. Okay, so that is pretty much it. That's how it's working. So existing session, no. Source zone protection, forwarding lookup, destination zone, security policy check, without app ID, session set up and assign the ID. Once it's assigned the ID, then it continues through here. If there's an existing session, when it looks up the session table, then we go straight down to this one, where the app ID and the content ID is done. If it's encrypted and there's an encryption policy for it, then we decrypt it and pass it through again. If there isn't a decryption policy, then that just gets passed on, and we do a sort of a check on that based on the behaviour of the packets, what we can actually see in the headers and things like this to try and work out what it is, and then we forward the traffic. And that's it. That's basically a session set up in Palo Firewall.
Okay, so enterprise management.
Palo Alto firewalls are managed individually and have no native ability to be managed collectively from a single interface. So there is no concept of so if you've got your firewall, you can manage that firewall individually, but there's no way of then joining other firewalls into that firewall. You cannot control other firewalls from that firewall. That would be down to the enterprise management platform, which is Panorama, of course. And Panorama can scale out to literally manage thousands of firewalls. Each Panorama instance can have a plugin installed to allow it to manage downstream Panorama boxes. The actual figures we'll go into later, but you can end up in a situation where you have up to 64 panoramas, and that each one can manage 1,000 firewalls. So you would end up. I don't know what kind of enterprise you'd be in, frankly. So virtual firewalls in the cloud. So VM series firewalls can run on most cloud platforms, both public and private. They run the same PAN-OS as hardware firewalls, with some exceptions that are cloud provider dependent, one of which being HA deployments have varying levels of support. So for instance, in AWS, you would not have there is no concept of HA between them. They'll sit behind an AWS load balancer, and then the AWS load balancer would then load balancer traffic to the firewalls. The VM series can be managed by Panorama either in the cloud or on premises. There's no restrictions on this. Security policy best practice: drop traffic to and from known malicious addresses. So within the within the firewall, there are dynamic groups, and some of them are maintained specifically by Palo Alto. There's no third party involved. And one of those, for instance, is the known malicious addresses, which through their research, through Wildfire and through telemetry and everything, are known to be malicious. So you would deny that traffic to and from and log. So you get bulletproof addresses. Those are the same again as it says on the slide. They're known hosting providers that have limited or no restriction on content and no logging. So they would tend to be favored by people that are phishing scams or anything like that, where you would not want to have anybody being able to trace back what you're doing. High risk addresses. Again, the addresses that, as it says, have been linked to malicious behavior in the past, or they've served some, but there's no actual direct evidence that they're malicious. So depending on your security posture, I guess you'd either allow and log it, or if you was really security conscious, you'd probably just drop it and then just deal with anybody that was trying to get to on a case-by-case basis. And then finally, MindMeld, which is an awesome product. It's still absolutely free. Yes, it takes a bit of working out and a bit of manual work, but I mean, that can literally aggregate hundreds, if not thousands, of feeds and present them to the firewall. The firewall can use them as a dynamic group, and that can be consumed by the firewall in exactly the same way as the list we were just talking about, and that way you can get threat information from everywhere. There's no such thing as too much threat information, really, unless you're trying to do it manually. So with things like MindMeld and so on, you can deduplicate it. So if you've got an indicator from somewhere, it's a bit like XOR sort of being the what's the word I'm looking for, being the progression from MindMeld, and you can deduplicate. So if you've got the same indicator from several places, you can just get rid of the others so you haven't got erroneous entries, and take whichever one is the most reliable three feeds. So if you've got reliability of A and reliability of C, you would take A over the top. Okay, so that's it for the security policy, this part of it, and we'll move over to the next section. So, as part of the PCNSE, we're going to go a lot further into rules and how security policies are built and how profiles are built. Okay, so for the first part of this, we're just going to look at the policy tab. We're going to look at the security policies, what type of policies there are, and how they're constructed. Okay, so let's say, for instance, let's have a look at the block apps one. Okay, so this is a best practice policy, and it's based on the fact that say Chrome, for instance, uses Quick. It's basically their own proprietary encryption, and it can't be decrypted by the firewall. So you lose that security and ability for, if you're doing SSL decryption, you lose that ability to view the traffic. So what we need to do is we need to block it, and then that forces the browsers to fall back to TLS, which we can decrypt. And so then we can go on and look at that traffic. So I've done videos like this before, but this is specifically for the PCNSE, so we'll really go in a lot deeper now and sort of concentrate on it. So, for instance, in here, you've got, name is fairly self-explanatory. You've got a name for the rule type. So you have universal, which is a rule, that's a default, and as it says, it applies to both interzone and inter and intrazone traffic. Okay, you have intrazone rules with one specified zone, and you have interzone rules. So if you had two interfaces in the same zone, but you wanted to still control, they were logically grouped based on whatever they're doing, their security risk or whatever applications is running on them, and you wanted to control that traffic between them, bearing in mind, if you remember, that intrazone traffic by default is allowed to flow freely. That's the type of rule you create, or interzone, makes sense, it goes in between zones, and it specifically there does not apply to traffic within a zone, even if the same zone is in source and destination. Okay, so this is going to be a universal rule. We would add a description here. So that's not correct. As you know. Okay, so we add our description there, and if we want to add any tags there, we can add tags there. Group the rules by the tag if you want to. So when you look at the rule base, you can then look at all the rules around that by the tag. And then audit comment is literally, so when you're looking through the audit logs, you have this comment, and you can set this later on. You can set this to be a requirement, so you can't create a rule or a commit without adding an audit comment. And then if you can, so you can look at the audit comment archive for security rule block apps, and there isn't one because I haven't created one. So as you put that audit comment in, that would be there, and you can follow all the way through then and see who's changed what and when they've changed it. Okay, so source is again fairly sort of obvious. So that's the source where it's from. So any would be any zone. Source address, any address. If you take that out, then it won't let you go any press OK unless everything's there. So basically, if this drops out from being blue, then you know that you've got an issue with the policy rule. Negate is simple. So if I was to put in here Cortex external IP, at the minute that's going to be any traffic coming from this. If I negate it, it's going to be all traffic except from this. Source user is add the source users, user groups, or specific users. Source device, I haven't got any devices. I have got so with the source device, I can say, well, if this device matches this profile, then that's allowed in this. So destination, again, is fairly sort of simple and straightforward. So destination zone, where it's going to, destination address, and you got negate again, so you can remove that. Destination device is the same in device again. The application, so we've got the applications, any. And what you'll find is if you add an application here, and then it's got a dependency there, you can add it to the current rule or add to an existing rule. So back earlier on versions, I think it was prior to 9.1, I think, there was a thing whereby you would put an application in here, and then you wouldn't have this box, and you may find that your application still doesn't work because it has a dependency, which you could go and find in the application's object. Okay, so when you're configuring the service, so let's say you have a specific SSL connection that runs on, say, 8443, you would then put the service in there and remove application default. If you have application default, that means it's going to categorize the application, it's going to look at the application, decide what the application is, and then the default ports that application normally runs on are going to be the only ones it's allowed to run on. And then URL category, you can block or allow URL categories. So you can say here, this is going only to this URL category. And so that's where you start to form your URL filtering. Okay, so the actions are deny, obviously. Deny, and these, I'll go through these because so deny, is it just, it denies the packet, but you'll get you can sometimes get a notification back at the host for that. Allow is obviously allow. Drop is drop silently, so it drops with no reset sent back. You can select just to reset the client, but leave the server open. Reset the server, or reset both client and server. And these are reset packets sent from the firewall. So if you're if you're on the inside and you're trying to get to a website that's blocked and you've got reset client, then you're during the policy, the traffic setup, your client will receive a reset, but the server won't, and then say, right, that's it. It goes to server and both client and server. Send an ICMP unreachable. So if we drop that, and then we can select send an ICMP unreachable, that would then send the ICMP. It do what it says. It would send the ICMP unreachable to the initiating host. Log setting. So this is actually a good example here. So normally you'd have log at session end, and that is because one way or another a TCP session will end, and then you can log that. If you logged absolutely all traffic as it's been started, then you will log at the initial SYN, and your logs will just be huge. So you tend to log at session end. However, in this particular instance, Quick runs specifically on UDP. So that will just, that has no defined end. So a log at session start so that I still see those logs going through the firewall. Log forwarding. So it logs to the firewall by default. However, if you create a log forwarding profile called default, then that is automatically added in there. So you don't have to remember to add a login setting into that as well. So other settings, scheduling. So you can create a schedule where this rule is active and not active, and that schedule can be hourly, daily, monthly, whatever. So I mean, scheduling really sort of would come into its own if you had if you had a specific schedule for update servers or something like that, you could schedule the access for that server for a period of time. It could go and do its updates and then automatically remove that access. Whether that is necessarily a good idea or not, I don't know, but you could do that. Or if you have users and you only want them on the network for a certain time, then as you can see, I've actually got a work schedule in there, which means that one of the laptops I use for my contracts, because it's on other people's networks, it's literally only allowed out during the times of the day where I'll be working, because I constantly forget to switch the thing off. So I think it's 6 o'clock or something like that, it stops the access to it. So QoS marking is QoS. We'll go into QoS later, and then that marks the packet. Okay, so profiles. So this now is all to do with you, as we described. If we can look here, so we have the policy, and then we have the security profile that is applied to it should the policy be allowed. Obviously, in this case, we've got a deny rule, so that isn't going to be the case. But we can select separate profiles. So we have antivirus, vulnerability protection, anti-spyware, URL filtering, file blocking, data filtering, and wildfire. Those are configured over in the objects for the profiles. However, we can then select them here. So any traffic that's allowed by this rule will then be subject to the home antivirus policy. To avoid having to do it like that, and this would obviously be best practice really. So if you have a department that has a specific amount of access, or they have certain things that they're not allowed to go to, or you have specific corner use cases, then you can create a group. I have no groups. Oh, I have got a group. I've got a server test group, and that is where you then define within the group profile, you would define all your separate profiles, and then you can put them in here without having to go through the whole thing of selecting them separately. And then profile type, none. So you've got nothing attached to it, which of course is in this particular instance is what we've got, because we've got deny rules. So there's no point attaching anything to it because it will never be seen. So then we have usage information at the end. Now there's a lot of reasons why this is here, but the first one is to give you a really clear view of when it was created, when it was last edited. That's always good to know. The hit count, when it was first hit, when it was last hit. Then the application seen and last app seen. Now on this one, there's not going to be anything because it is literally just, it's what we're doing. It's what we've got. So it's just quick and that's it. Nothing else is going through it. However, if I come out of that and pick one that is, no, that's a bad one because that's the list there. That's a deny rule, so that's stupid. Let's try. This is always a good one. Hang on. Let's try internet access. Okay, so if we go to usage here, so here we can see how much traffic is on it. Application seen, last app seen 0 days ago. So this is seeing new apps, and then you can view what applications are seen there against the apps that are on the rule. Now in this particular instance, you can see I've got any application, an application default. Now that is because I want to avoid any issues with internet access because I'm at home and I do my testing with a user account, and everybody else who would whinge at me if the internet stopped working does it with this rule. However, in this particular instance, okay, what we could do is we could take these and we could add to this rule or add to another rule. So if you were to create a rule, so where you would do this, so you put your Palo Alto firewall in and you are not wanting to break everything, so you create a rule like this, so everybody's internet access keeps going. Then above this rule, you would have an application rule. And the difference with a home network, obviously, to an enterprise network is the fact that in the enterprise, you're going to get a lot more structured and probably a lot smaller amount of applications, just plainly due to the fact that people are working. Whereas here, it changes every 5 seconds. So you would add that then to the existing rule on the firewall. So once you've added that to the existing rule, you can build up that rule based on the traffic that's going through, and then what you'll find is that gradually more and more traffic will hit the rule above, and it will stop hitting this rule. Whereas if you add this to this rule, and then a new application comes along, it will be denied. But you can add it to this rule if you are happy that it's going to work. Okay, and then create a cloned rule as you create a cloned rule of this one and do the same thing as we were saying before. And then when you go to create a cloned rule, it'll give the option to clone it either before or after. Always clone it before, otherwise you won't see whether anything's hitting it or not. Okay, so that really is the security policy rule